Alright, hello once again. Jeff Scott of Rankin Technical College. And as part of the Rankin Technical College AWD, or Application and Website Development Program, and in particular the AWD1100 C# Programming Language Fundamentals course, I've been doing a series of video presentations based on the book for the class, which as you can see, is Muroc C# 2015. So far I've finished the first 3 sections of the book. So I did the first 3 chapters in Intro to Visual Studio, the next 8 chapters, the C# Language Essentials, and the next 5 chapters on Object-Oriented Programming, which brings me to database programming. So I'm going to go through Chapter 17 right now. As I mentioned previously, in my humble opinion, 18, 19, and 20 are the, quote, older ways of doing this stuff, whereas 23 and 24 are the, quote, newer ways. So I'll spend less time on 18, 19, and 20 and more time on 23 and 24. All right. There are a lot of ways to learn about databases. I'm going to give you my take. All right. Which, is it the best? Of course not. It is a way of learning about this stuff. So, about 40 slides here. Notice that we have 9 knowledge objectives here. This is an introduction to database programming. Describe the hardware components of a typical multi-user system. Describe the software components of a typical multi-user database application. Explain how a table in a relational database is organized. Explain how tables in a relational database are related. Describe the use of what is typically referred to as CRUD. Rather than select, insert, update, and delete, it's usually create, read, update, and delete. Describe the use of these ADO, which is ActiveX data objects, .NET components, a data adapter, command, connection, data reader, data set, and data table. Compare the structure of a data set with the structure of a relational database. Describe concurrency, optimistic concurrency control, and last in wins. And finally, describe 2 ways that you can create ADO.NET components. So, this is a typical client-server system. The clients don't have to be desktop machines. They could technically be phones. They could be tablets. They could even be something else. But you've got clients, and you've got a network, typically referred to as the cloud here, which is really one or more other servers that would connect to one or more database servers. So the information flows back and forth between these. The 3 hardware components are the clients. They're typically going to be PCs. The server is a computer, a bigger computer, maybe not bigger size-wise, maybe bigger size-wise, but it's a computer that has a lot of storage, so it can store the files in the databases of the system and provide necessary servers, or services rather, to clients. When it stores databases, as mentioned, it's typically referred to as a database server. The network are the cabling, so the physical connections and the non-physical connections through routers. In other words, do you have a LAN? Do you have a local area network where machines might be physically cabled to one another? Or do you have a WAN, a wide area network, where they're not? As an example, I work in Wentzville, Missouri. We are approximately 40 miles west of St. Louis and our St. Louis Rankin campus. That would make no sense, plus how would you actually dig 40 miles underground to do that? So we don't have a physical connection, but we have, through routers and the like, we've got a wide area network connection. In the room that I'm in right now, the machines are physically cabled to one another. So there's a LAN or a local area network connection. All right. So they mention this stuff here. I'm going to let you read that yourselves. You might like the definition I gave better. You might like the definition in the book better. Either way, in the end, it doesn't really matter. Now, this whole thing has, over time, has always been referred to as a client server type of system. All right. Many many books will still refer to it in that way. The client is the user machine, which in this case will be querying, probably may or may not be directly a database server. The queries might go to a server which routes it to a database server, which answers the queries or questions, sends it back, usually to another server, which sends it to a client. All right? So to manage this, you need some kind of a network operating system. Could be Windows, could be Linux, could be something else. To store and manage databases on this type of system, you use what's called a DBMS. A DBMS is a database management system. All right, three of the more popular ones are Microsoft's SQL Server, which we'll look at in here. All right, Oracle, which we won't look at all in here, and MySQL or MySQL, which was bought by Oracle a few years ago, but is a nice RDBMS, and it's free. Now, you can download free versions of Oracle, I believe, and free versions of SQL Server, but they won't have all of the capabilities that a paid version will have. All right? The processing that's done by a DBMS, as it says, is typically it's on the back end. The database server is the back end. What you end up showing, so this is back end stuff, this is front end stuff. The application software, as it says, does the work that the user wants to do. All right, you might buy that where it's totally finished for you. You might develop it yourself. It might be a hybrid where you purchase something that's partially done and you add to it yourselves. All right, an API is an application program interface. As mentioned right there, it provides the interface between the application and the DBMS. To put it simply, it's kind of a contract, for lack of better words, between you and the software, where the software says, I will provide these services for you, and in return you say, okay, since you will provide me these services, I will ask for those services in the way that you expect me to ask for them. So the processing done by the client, front end, done by the server, back end, the client is typically referred to as the front end. All right. The application software, as it says, communicates with a database management system by sending queries. A query is a question. All right. So when I go in and I work with this stuff, all right, I can ask a question and I have to do it in a certain way. That way typically involves using directly or indirectly SQL, the structured query language. Now, that has been around for approximately 45 years. I don't know about you, but tell me many things around here that have persevered in the information technology world for 45 years. In a client-server system, as it says, the processing done by the application is typically divided between the client and the server. You typically have what's referred to as a fat server, thin client, where most of the work is done on the server, or a thin server, fat client, when more of the work is done on the client side. Now, in a file handling system, all of the processing is done by clients. That's not a database. Although clients, as it says, may access data stored in server files, none of the processing is done by the server. So a file handling system is not a client-server system. Now, here's an example of a database. And I'm going to give you some of my own stuff in here. All right, good, bad, or indifferent. And again, these are my definitions. All right, first, we have a character. So what's a character? I'm going to say it's anything you can enter from a keyboard. And I'm going to put an asterisk there because there are other things that are not on a keyboard that you can also use. All right. So, what's a field? And a field is one or more related characters. All right. So for instance, if I had a field called first name, in my case, it would be 7 characters, Jeffrey for my first name. All right. If I go and I grab that field, and field, it can go by other names too. I'm going to put this in here because sometimes it's called a column. All right. And a record is one or more related fields. All right. And a record is also known as a tuple in some places. Years ago, I worked for AT&T Bell Laboratories before they split, and I was working on a database, and I got a call from a guy in England, and it was one of the first times, maybe the first time ever, I had spoken with somebody with an English accent, and basically, and I can't do an English accent, but he said, like, what you doing with me tuples? And I didn't know what he was talking about, but he meant tuple. All right, so what's a table? One or more related records. And what's a database? One or more related tables. So you can see how each one of these builds on one another. Fields are composed of characters. Records are composed of fields. Tables are composed of records. Databases are composed of tables. And all of these say one or more related. A field like, for example, middle initial would be a single character. If you only had one person working for a company, you might only have one employee record. In a very simple application, you might have only one table. Again, even if you have a few of them, they might be all contained in only one database. So again, these are my definitions. By no means am I claiming they're the best. By no means am I saying they're the only ones. So let's look at what they show here. This is a table. This table has 1, 2, 3, 4 fields in it. And at least, if these are all of the records, it has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, it looks like 16 if I counted right. 16 records. Each record has 4 fields. You can see that the product code looks like it's a combination of numbers and letters. The description are letters. The price is probably a decimal type of value. And the quantity on hand is an integer or whole number value. So when you use SQL, the structured query language, you are working with what's called a relational database. All right? When you work with a relational database, as mentioned here, you use tables. So this is a table that's used to store and manipulate your data. Each table has 1 or more records. Records go across horizontally. And each record or row contains 1 or more fields. They go vertically. Most tables have a primary key. I like to keep my definitions short and sweet. A primary key is what I call a unique record identifier. So it would be product code here. Each of these is unique. Some database management systems allow you to define 1 or more non-primary keys called unique. All right, so for instance, if I had in here, let's say this was stuff about an employee, and this was employee number, and that was the primary key. I might also have a field called social security number, which I wouldn't make a primary key, but I could make a unique key. A table can also be defined to have indexes. What's an index? It's a way that internally it allows you to search a database faster. So if I'm going to be doing a lot of searches based on quantity, I might want to set an index up on the on-hand quantity field. Now, when you've got a field like a primary key, it's automatically indexed. Why do you use an index in a book? So you can quickly find something. And it's the same kind of way in here. So here's two related tables. Notice that both tables have an invoice ID, all right, but they have different information. This invoice ID in this invoices table, this would be the primary key. However, it's the customer ID over here that's the primary key, and the invoice ID is added so that I'm able to link these two tables together. So this is known as a foreign key. There's a lot of definitions, a lot of junk to throw at you here. All right. So as it says, the tables in a relational database are related to one another through key columns. When you add a primary key from one table into another table, it's used as a foreign key. This would be a one-to-many relationship. Every one invoice could have 0, 1, or more line items. Usually a foreign key corresponds to the primary key in a related table, as I mentioned. When two tables are related via a foreign key, the foreign key is referred to as the foreign key table. All right. This would be a one-to-many relationship. Every one invoice could have 0, 1, or more invoice line items. All right. Seems like a good place to stop right before we go into the Server Explorer design window. All right. So we'll stop right here.